In section 9.6, we're going to add one more tool to our toolbox in terms of solving quadratic equations, and that's going to be using what we call the quadratic formula. So along with the quadratic formula, there's some good news and some bad news. First of all, the good news is that this formula is going to work for any quadratic equation, doesn't matter what you start with. But the bad news is just look at it. There's a lot of stuff that goes in the quadratic formula, but it still just comes down to getting this kind of equation into standard form. Ax squared plus bx plus c. I'm going to be using those three coefficients, a, b, and c, so something like 2, 3, and negative 5. And in that formula itself, I'm going to be plugging those parts in. So whenever I see a b, I'm going to plug in a 3 from that equation. If I see an a in the formula, I'm going to be plugging in a 2. And if I saw a c, I'd be plugging in that last constant. I'd be plugging in a negative 5. So a lot of this is just basically plugging into our formula and then simplifying. But just like that last question, we need to start in standard form before we use this formula. So you might take a step at the start of a question like our next one. So if I want to use the quadratic formula, I got to get it into my standard form, which in this case means we got to subtract 2x from both sides. That way I get x squared minus 2x minus 8 equal to 0. And again, now we have our ax squared, bx, and c. And if I'm going to use my formula, I can use that formula from above. If I plug in, again, it starts with negative b, so in this case that's negative 2. If my b term is already negative, I still got to plug that in as a negative from the formula. And next to the formula, I have plus or minus, square root. In the formula, I have b squared, so that's negative 2 squared, minus 4 times a, which a is just a 1 here because we don't really have anything written in front of that x squared. And the c would be a negative 8. Again, remember that the negative sign stays along with it. And plugging into the formula for the bottom, all I have is 2 times a, so in this case that's 2 times 1. Again, all I'm doing is I'm using the same formula. This would be one that you could write down on the start of your homework, just to remind yourself that it's not going to change. Taking a, b, and c and just plugging those parts in. A was 1, b was negative 2, and c was negative 8. So now we just got to simplify this. So a lot of these questions are going to end up being a lot of calculator work. But we could do this one by hand. Negative of negative 2 would change that to a positive. Plus or minus square root. Negative 2 squared would be a 4. And negative 4 times negative 8, kind of simplifying that a bit, would be a positive 32. On the bottom, 2 times 1 is just going to give me a 2. So really all I'm doing is I'm taking this and I'm simplifying it down further step by step. 4 plus 32 just makes this a 36, and I'll simplify everything else after. Square root of 36 we also know is 6. So when this says 2 plus or minus 6 all over 2, that means if I take 2 plus 6, I get 8 over 2. Sorry, I should leave this as an equal sign, so we're just trying to simplify again. And 2 minus 6 is going to be negative 4 over 2. Again, I'm just using this plus or minus as two operations. 2 plus 6 is 8, 2 minus 6 is negative 4. They were both underneath a 2, so I have two separate solutions as 8 over 2, negative 4 over 2. One last step is to simplify our fraction. So we get two possible answers here for x. We get 4 and negative 2. And notice from the very start of this question, we actually know how to solve something like this a little bit easier using factoring. So if I'm looking for numbers that multiply to get negative 8 and add to get negative 2, negative 4 and positive 2 would work. So if I use x minus 4, x plus 2 equals 0, I would end up getting the same solution as what we found. But again, the nice thing about quadratic formula is it doesn't matter how we start. This formula, if I plug everything in and simplify it, will always get me a solution no matter what. We will see cases, and we have seen cases, where factoring by itself didn't work. So practicing those same steps on your own, I'm just going to reveal our answer in terms of what we got. Again, first step is to get this into standard form, so I subtracted 21 from both sides. Then just by using that quadratic formula, again, it's a long formula, but I'm just plugged in negative 4 for b, plugged that in a couple times, then 4 times a times c, and then 2 times a on the bottom again. And I'm just simplifying. So negative 4 squared is 16. Negative of a negative is a positive. Negative 4 times negative 21 is positive 84. Add these together, I get 100. Take a square root, I get 10. And remember, this plus or minus means we need to do two operations. So that's 4 plus 10 to get 14. 4 minus 10 to get negative 6. And then since it was all over 2, I got to simplify those as two fractions. So again, sometimes a lot of steps to simplify, but nice thing is that we're not changing that formula. And remember, back to that original question, there is a faster way to get this answer if I would have used factoring. But remember, it's not going to work on every question, which means it's going to be helpful to identify the fastest way to solve a certain formula. So we've been over graphing, and I put these notes off to the side in terms of what sections you can find these methods from. Graphing we don't solve too often. If I need a picture of a graph, I'll ask you to graph it. But most often we're not going to find solutions that way. Again, notice it says if you have a graphing calculator. We did see a method that's helpful if you have square roots, if we have no x term. We're going to see from the choices below what that's going to look like. Factoring, I already said if I use that x method on the previous one, factoring is actually a faster solution. So if I can factor it easily, that might be a good method to choose. We had completing the square from 9.5. I won't usually use completing the square too often, but it is an option if you're comfortable with it. And 9.6 is when we're adding in our new quadratic formula. So that's when I can't factor it easily or can't factor it at all. So in terms of choosing the best method, I kind of just wrote all of these. It's really up to you how you solve them the easiest. But notice that anything with just like an x squared term, if I don't have x, if I just have just another constant, that's fastest to solve using square roots. Next question, I could solve this using factoring. Think of two numbers that multiply to get negative 30 and add to get negative 1. And next question, this is one that maybe it works with factoring, but I don't really want to bother with coefficients that large. I could just plug those into quadratic formula and be done with it. Our last example is one that you could solve using completing the square, but notice that if this term is odd, usually that's going to be a little bit tougher. And since we can't factor it either, I would also use quadratic formula for D. There's another row here as well, so just revealing what I would use on the next four. Same thing as what we saw in C. If the numbers are big and it's going to be complicated, just plug that into quadratic formula. If it's not complicated, I could just use factoring a lot like B. And again, if I just see an x squared term and a constant, that's a quick way to just use square roots. And going back to H, this is another one that we can't factor just like D. So if factoring doesn't work, I'm going to go straight to quadratic formula. And there's also one part about that formula that can reveal something about our answers in general. We've seen that we can have two solutions, one solution, or no solutions at all if I have a quadratic equation. And I can determine that really quickly if I look at what we call the determinant. Or sorry, not the determinant, the discriminant. So discriminant is actually what we call that piece inside that square root, the b squared minus 4ac. Notice this is still the quadratic formula. Just this part inside of the square root we're going to call the discriminant. Because based on this number inside the square root, that's going to tell me if it's positive or 0 or negative. I'm going to have two solutions, one solution or no solutions. Again, remember that something strange goes on inside that square root if I try to use a negative. So breaking down those three options on a graph, we're going to back this up further in the chapter, but if I have that discriminant and it's positive, I'm going to notice that on a graph, it's going to cross the x-axis twice, which means I have two solutions. If we find the discriminant is 0, and again, if I plug that in, negative b squared, b squared minus 4ac, and it comes out to 0, that means that it would touch the x-axis at one spot for one solution on a graph. And if the discriminant was negative, it's not going to work with my quadratic formula. And we could also see from the graph, if it doesn't touch that x-axis, it's not going to have any solutions at all. So let's just look at the discriminant. Again, discriminant is just the part we call b squared minus 4ac. We do have to start this question like we did the last time. I got to get this in standard form. But once I do, 2x squared minus 3x plus 5 equals 0. Now I'm just plugging in these pieces into my discriminant formula. So b is negative 3, so b squared minus 4 times a times c. I just want to simplify this just like we did with our equation. So 9 minus, I think this is going to make 40, is going to make negative 31. And again, we don't really need to know anything about this value in particular. I just need to know that if that value was negative, so as long as that discriminant is negative, I know that I'm going to have 0 solutions. So I can just say no solution for this one. Again, just because our discriminant was negative, if I tried to use this inside my quadratic formula, a negative inside of a square root is not going to work. So trying the same thing with the next one, if I just plug that into b squared minus 4ac, I, again, have to get this in a standard form first, but once I do, b squared is negative 5 squared minus 4 times a times c. If I get a positive solution from this, again, positive means that I'm going to have two solutions. So just by looking at the discriminant, we don't have to say what the solutions are. We just know that there's going to be two of them.